Hello, in this video I'd like to present a machine learning model that I've developed in order to predict English profanity words. So recently I got a problem. So how to predict whether a given single word is a curse word or not, or maybe this is the normal word. And unfortunately, the hard coding approach is not working here because there might be very creative users who spell fuck with spaces or replace the U with the asterisk or whatever. And encode every single one is really impossible. So instead, we can use a neural net that would be taking the word as an input and predicting whether this is the profanity word or a normal word. So essentially, this is the binary classifier. So I'd like to demonstrate what kind of end result that I came up with. But before that, let's quickly walk through the notebook that I've developed. Also, I have the codes in the normal Python files, and the link to this repository would be in the link below the video. But for the sake of simplicity and clarity, I'd like to demonstrate things in the Jupyter notebook, although I'm not using these for development, but they're quite good for presentation. So let's quickly inspect the data to give you a feeling what am I working with here. So let's start with the lines and let's give like 50, let's say. Okay, we need to run the code first, obviously. So these are the pairs. So this is the bare txt file. Every line is like the word itself and the label. So this is not a curse word. This is the curse word. This is the curse word as well. And this is like not a curse word. And also, etc., etc., etc. So what we need to do with this now, so we want to split this into words and labels. Yeah, it looks like CSV format, but I just call it input txt. So if we have a look at just the words, these are just the words. And if we have a look at labels, then these are the labels. But obviously, we cannot work with them directly like this. So we need to be able to encode the word eventually into the PyTorch tensor. But for now, just yeah. So characters is all the vocabulary, like all the unique characters that we have, plus one, this one for the empty element to represent the empty element. And as to I is a string to integer mapping from like every character gets mapped to the certain integer, and that's the way how the characters within the word are actually encoded. So this digits later would be translated into the Torch tensor, PyTorch tensor. So the encode word simply converts all the letters within the word, within the given word, into the, let me show you, into this kind of vector. But also it adds the padding of 0 so that the eventual length is like 22 characters. Finally, we encode everything into PyTorch tensors. So these are the words being encoded into a single PyTorch tensor, and the size is, the size, the shape is like this. So we have 1,787 words, and each word is 22 characters long. That's the maximum length that we have. And the y, respectively, is the number of labels. The model has the only function to forward the weights, and it returns logits and loss. And in case if we're training, the loss would be calculated using the binary cross entropy. And by the way, I'm using the bare logits. I'm not doing the binary cross entropy on probabilities, but on logits instead. And obviously, in case if the targets are none, in case of inference, and when we're testing the model, we're not training but testing, we're not sending the targets here for validation, so just none. And in that case, we do not return the loss. The loss would be none. And then we just convert a single logit into the probability on the during the inference stage to get the actual result of the network output. The get batch would take the random sample from the entire data set, and this is what I like the most. So this IX creates, based on the batch size, creates the range of random indices from the model, and then we can index the data. So either the training data, if we're calling this for training, or validation data, if we're calling this for validation. It then gets indexed by this index range, and that's the way how we can obtain the chunk of data, the batch. So we just sample the batch from the training data. So we forward uh, this data through the model, and we're getting the largest and the loss in return. Then never forget to initialize gradients and backpropagate the loss, and then consider the next step within the optimizer. And we essentially repeat this over and over again until the loss gets minimized. The less the loss we have, the better model prediction quality we have. So just run it once. So yeah, my computer starts working hard now. My poor Raspberry Pi. And okay. Yeah, just mask the indentations. Yeah, now there is a train key, which is fine. Iteration, yeah, for the step 0. So the initial loss is like this, quite a big one, yeah. And then after 100 times, should print the updated value. Yeah, because of the video recording software, it just goes like 2 or 3 times slower than it usually does. So we got some minor improvement, which in theory means that the model training is going on properly. Since the model is quite random at the moment, running this test doesn't quite make much of a sense, but as a proof of concept, yeah, so Google accuracy 100, so probably doesn't see bad words at the moment because it didn't train a lot. So if we say hello, it says like it's not profanity, but the value is a little bit too high. If we say fuck, yeah, it's also like it doesn't distinguish much. So yeah, because this is the very early stage, the model is quite random. Okay, so after a while we got an update. So it's like the loss is going down, and this means in theory that the values over in here should be a bit different. So let's quickly check this out. Okay, now we got a dramatic change in bad accuracy, interestingly. So we did fuck. Okay, now fuck is distinguished as a profanity word, which is good. What about the hello? And hello is now clearly not a profanity. Now let me show you how this testing model querying thing works with a fully trained model that went through 5,500 iterations. So just running python test.py, and it shows how many parameters this particular model has, so 54,209. And it now walks through all of the training samples, so almost perfectly recognizing curse words and quite good at recognizing non-curse words as well. So just to show you, so this is the curse and this is not, okay? This is not the curse. This one, I don't remember how it's labeled essentially. Need to check this out. But there still might be some false positive. I think duck gives the profanity, although not as big as fuck. Yeah, the fuck gives 0.9. Duck only gives 0.7. So this is the classical example of the false positive numbers. But the good news is that there are not many of those. I would say that this was really fun, and I really enjoyed fine-tuning the model. And yeah, I spent a couple of days on this, and at the moment, like as a first complete project, I feel quite satisfied about this. Anyway, so you guys, this is from my side. Thanks for watching. Hope to see you next video. Till then, cheers.